Hi class. In last video we learned about stacks and today we are going to talk about queue data structure. It's the same chapter of your book, chapter number 20. Please read this chapter if you haven't, because it's very important. Video lectures, they do not substitute reading the chapter. I can ask you anything what your chapter contains. So let's take a look at queue. So first of all, what we learned about stack. Stack is first in, last out data structure. So here's our stack, and we only can access top element. We can push, we can pop, and we can pick. Push is to add or to insert element, and pop is to remove element, and pick just returns value of the top. And again, stack, you can think about this like pile of books or something like this. You cannot access anything but top element, and you can see it here. Queue is a little bit different. Queue, you can think of queue as, let's say, a line in the store. And here I have actually some picture. It is a queue. And queue has front element and rear element. So that's important to understand that this time we can access front and rear, but we will talk about this later. So queue is a data structure in which the elements are added at one end, called the rear, and deleted from the other end, called the front. So again, it's just like a line in the store. It's first in, first out. So, for example, you go to the store, and if you got there first, you will be the first one who will leave the store, or cashier in this case. So a queue is a first in, first out data structure. As in stack, the middle elements of the queue are inaccessible. So you cannot access anything. And it's important to understand that you can insert elements only at the end. Because when you go to the store and there's a line at cashier, you cannot go through the line and be the first one, right? You can think as you insert yourself to the end of the line. And the same with the queue. When you want to insert something, you insert it to the rear or to the end of the queue. But when you want to remove something, you only can remove first element. So you only can remove front. Here's some operations of the queue. InQueue and DQueue. InQueue is to insert and DQueue is to remove. That's how we call it. If in the stack it's push and pop, here in queue it's InQueue and DQueue. And here you can see queue here, which has front and rear. So if you want to insert, you InQueue to the rear. If you want to remove, we call it DQueue. You only can remove it from the front. Just like stack data structure, queues can be implemented using arrays and linked list data structure. I'm going to show you an example of linked list implementation. Of course, the first thing we need to do when we start working with linked list, we need to create a node class, which will contain our fields and constructors. It's the same what we used for linked list or for stack linked list. I'm just going to use it. But you always need to remember, you work with linked list, you need this node class. So I'm going to create a class, public class. I will name it myQ linked list. I'm going to have two nodes here. Node first and node, sorry, not first, node front, which is first element of my first node of my queue, and node rear, which is last node. Of course, I'm going to have my constructor. I will just set up front to null and rear to null. So again, basically what it means, I'm saying my front is null and my rear is null. So instead of typing in different lines, you can use one line, right? Front equals rear equals null. Well, not equals, gets. Let's write a method is empty that checks if the queue is empty. Yeah, is empty. So it returns true if the queue is empty, false otherwise. So again, it's very similar what we did in last lecture with the stack. The only difference now, it's not a stack, it's a queue. And what is difference between queue and stack? Stack, you add to the top and you remove from the top. In queue, you add to the front and you remove from the, you add to the rear and you remove from the front. Sorry. So public boolean is empty. So now just let's think when our linked list is empty, how do we know? So it's empty when front equals null. So if front equals null is empty. So return true. That's what it means, this method. And it's exactly the same what we had with the stack. There's no difference in this case, in this method. So now let's create a method in queue that adds a value to the end of the queue. So remember, I do not have any other options. It's always to the end. And in Q, I will put here some remark for you. It's insert. We call it in Q. So again, you cannot insert in the middle. You cannot insert at the front. It's not fair. You get last, you will be at the end, okay? So it takes parameter. So I'm working with strings, if you noticed. It can be any data type, it can be integer, it can be anything. I decided to do it with string. So my parameter will be string s, which is value to be added or inserted. So public void enqueue string s. So how we add a node to the end of the list? So first of all, I'm going to create some node here. And guys, it's nothing new for you. It's just a regular operation of linked list, where you add a node to the end of the list. So nothing new. Create a node. So if you do not understand linked list, please use my office hours, use peer leaders, or review the lecture on linked list, or read this chapter again, because it's very important to understand linked list, and that's why I decided to show you linked list implementation. So create a node containing s, which is string s, which you want to add. Now we need to check if it's empty. So if our list, if our queue is empty, what do we do? Our front equals rear equals n. So our node will be both front and rear, right? Because it was empty list, and now we have our node here, which is both front and rear of the queue. And else, we need to set rear next to point to our new node. So set rear dot next to point to that node. Of course, it's not enough, because if you remember, we still need to move rear. So that it points to the newly added node. So, and that's it for this method. We are done, and we already have seen it, right? So again, we create a node which contains string s, which we want to add. We need to check if it's empty, because if it's empty, our new node will be front and rear. And else we need to set rear.next to so it can point that node. And then we just need to update rear equals rear.next. Okay, so that's it for this method. And actually now let's write a method pick. It's I forgot to mention, it's also pick, just what we have with stacks. The pick method return value at the front of the queue. So it returns item at the front of queue. Oops. Item in the front of queue. So if we want to pick, we can only pick front. You remember it's very similar when you remove or when you dequeue. It's only front. You cannot pick anything else but front. So let's do it. Public string, because it's going to return value, and my value again it's string. Public string pick. Now we need to check if it's empty or not. Why? It's the same reason, because if we try to return something that doesn't exist, it's going to crash. It's the same what we did with stacks. So here I'm going to put that it throws empty queue, empty queue exception when the queue is empty. So, and here, of course, we need to let our main method know that it might be throwing the exception. Empty queue exception. That's why we need to check first if it's empty or not. If is empty, throw new empty queue exception. So we already did it with stack, and this time it's just the difference is it's not stack anymore, it's queue, but it's very similar. So, and here I'm going to put some message. Queue is empty. Of course, some drama. I like drama. Well, not really. Okay. And now we can pick. So I'm going to create string which I'm going to return, and we know it's front value, right? It's very straightforward. We have front and we want to pick something at the front. And in linked list, we can access node, value of the node by typing that value. So why it's that value? Because my string, I name it value. Maybe for you, it's data or something else, but for me, it's value. And now I'm just going to return string. So, and that's my method. Okay, are we done? Well, not really, because we still need to create this exception, right? Let's do it. So public class empty queue exception and constructor. Oh, of course we need to extends exception. And we are going to use a constructor of exception class. So I'm going to create constructor here for my class. And then I'm going to call super constructor of exception class string s. And that's it. So it's exactly the same what we have done before, and with stack I just changed the name, right? So now we have this method, and let's write one more method. And one more method, as you could guess, is going to be to remove front node. And we call it dequeue. So the dequeue method removes and returns the value at the front of the queue. So return item in the front of queue, and of course it's going to be the same exception throws, because if we're going to remove something that doesn't exist, it's going to crash. That's why we need exactly the same exception. Now let's write a method. So public, since I'm going to return the string, my return type is going to be string, and name of the method is dequeue. It also throws this exception. It means I also need to check if the queue is empty, and if it's empty, I need to throw this exception, which will say, oh no, queue is empty. I'm still going to create this string, which is front value. That's exactly what I want to return and remove. So store value to be returned. Okay, I don't know why I did this. Okay. We need to update our front, right? So move front down past the node being removed. Okay, and now I just return string. So again, if we take a look at this class, I created node front and node rear because sometimes I need to use front, sometimes I need to use rear. When do I want to use front? When I dequeue, which is removing, or when I pick, which is return value of the front. And I want to use a rear only when I want to add something to my queue. Well, not only, because if you take a look, we use front, for example, when we check if it's empty or not, or yeah. So I created isEmpty method so I can use it in my enqueue and pick and dequeue methods. That's the reason. Next, I have enqueue method, which is insertion, which inserts string to my queue at the end or at the rear of the queue. And we have seen this method before. It's nothing unusual. It's just regular linked list method to insert node to the end of the queue, or of the linked list, sorry. And I have pick method. Pick method is very straightforward because you just need to return front value. The only thing we need to be aware of this exception. When our queue is empty, we need to throw an exception, otherwise it's going to crash. And dequeue method is to remove a front element. And we all know how to remove first element from the linked list because it was in your quiz. Basically just one line of the code which removes front element, first element of the linked list, right? You already know this, it's nothing new. So the only thing you need to take care of case when your queue is empty. And of course, since we want to return front value, we will do this. So I just created a string where I want to store front value that I'm going to return, and I'm returning it here. So it's very similar to the stack. Now it just have some other limitations, right? Let's test it. Let's write our tester class. So I'm going to create public class and I'm going to name it my queue linked list tester. just main method. Create your object. I'm going to name it Q. Now I'm going to in Q some string, let's say EPCC. Then, okay, before I do that, I want to check if it's empty or not. System out print line is empty. Now I call empty method. Yeah, let's see. Compile, run, what's this one? Run is empty, true. Now I'm going to add to enqueue EPCC, and I'm going to check if it's empty after insertion or not, and I misspell it. Somewhere, oh, I misspell it here. Enqueue, yeah, run is empty, false, because I just added. So let me add couple more strings. Let's say Java, computer science. Now let's take a look what at the front. System out print line. What is the front value? Name of my object Q, and name of the method is pick. Okay, of course I cannot, I have this error because I never try and I never catch anything because of the exception. So I need to try statement. Let me fix it. And catch. Empty stack, oh, it's Q. Empty Q, exception. Name of the exception, I will name it E. And some print statement here. I'm going to print E. Now compile, run, and we can see what is the front value, EPCC. Now let's remove front value to see what is going to be in the front. So how do we remove? removing dequeue. Remember, it's going to return the value to be removed, so that's why I'm using system out println here, because I want to see what it returns. So removing EPCC. Now I'm going to pick again to see what is the front. Compile, run, and what is the front value? Java. Let's say I want to remove again and again. Compile, run, removing Java, removing CS. Now I'm going to pick again to see what happens with my queue. Run, and it's saying, oh no, queue is empty. Of course it's empty because I just removed everything. Let's take a look at array implementation of queue. When you create your class, of course, you have to have a front as well, which keeps track of the first element. Queue rear, or just rear, keeps track of the last element. And since we are working with arrays, we need to specify the maximum size of the queue. So capacity, right? Array capacity. So you can see here queue with array implementation. It has indexes 0, 1, 2, 3, 4, and 5, and it has front and it has back. In this case, it's back, but it's the same as rear. It doesn't matter how you actually name it. So it has ABC elements. When you want to insert D, we say in queue D. So it goes right after C to the rear of the queue. If you want to dequeue, and you can see it doesn't have any parameters. Why is it so? Because we don't have any options, right? We just dequeue whatever is at the first position, which is position number 0. So it just removes A from your queue. Yeah, here just example of constructor. Your default constructor, you need to specify size of the queue or capacity of the queue, and initialize front with 0 and initialize rear with capacity -1, and you have counter here to keep track. You're going to have isEmpty method that returns true or false. It returns true if your queue is empty, false if it's not empty. If you remember, with stack, we had this variable named top, right? Here it doesn't make sense to name it top, but it doesn't matter. You can name it count or counter. So when counter is 0, it means your queue is empty. That's how you check if it's empty or not. And also you can check if it's full. Full when your counter reaches the size of the capacity. So if counter equals capacity or size of the queue, it means it's full. So this method will return true if counter equals size of the queue, and false if it's not. And those other methods I recommend you to read in the book, because probably you haven't seen any generics yet. It's going to be in your Java tree concept, but yeah, you can see what actually happens here. So it also has enqueue method. For example, here's your queue and you want to enqueue tree, which means you want to insert tree. So your tree or your front will be the same as rear, and it's going to be tree, right? Because it's just one element, because you inserted it, you enqueue this into empty queue. Then you want to enqueue 6, so it goes to the next element, to the next position, right after 3. So you will need to update your rear. Then you want to enqueue 9, and it goes to the rear again, here after 6. So when enqueuing, the front index is always fixed and the rear index moves forward in the array. And you can see it here. When you enqueue, front is always the same. It remains the same. But what you do, you update, you move forward your rear index, right? So first it's the same front and rear, because it's just one element, and 3, it's first element and last element at the same time. When you enqueue the next element, your front remains the same and rear is updated. And same as here. Yeah, and you can see here some example, but I think your book has better example just because of those generic types, but hopefully you can understand this. So if you try to add, to dequeue anything to your queue which is already full, your program is going to crash. That's why you need to handle this situation. That's why you need to create your overflow exception. So dequeue method, for example, here you can see some queue which contains 6 and 9. 6 is the front and 9 is rear. You dequeue again, you don't need any parameters here. You have no options. It's just going to remove front and that's it. That's how queue works. So you remove first element, right? Which is 6 in this case. And when you remove, when you dequeue, your queue looks like this. It's only 9. 6 was removed. So when dequeuing, the front index is fixed and the element at the front the queue is removed. So front element is removed. Move all the elements after it by one position. So basically what happens, you have front and you have a rear. You dequeue and it removes front. And you can see front is still here, but you need to update your rear, right? You need to shift each element in your array by one to the beginning of the array. Yeah, here's some example. Just do not forget, when you dequeue, you always need to check if it's empty or not, because you need to handle this exception. And of course, you need to update your counter. And how do we do this? It's just count minus minus. Because when you in queue, you need to update it plus plus, right? Which means, in this case, it means count minus 1. Okay, and of course there's peek method. I'm not going to show you implementation. I mean, I explain it, but exact implementation is in your book, and I'm not going to show you just because it's in your assignment. I just don't want you to copy my lecture, I guess. So you are responsible to read and to see examples in the book, so you can actually complete your assignment. Just let me know if you need any help with this assignment or with topics. Also, do not forget to use peer leaders, or just email to me if you have any difficulties. And I really hope that you read the book, because, for example, in the last assignment or even in the test, I put something directly from the book, and some of you weren't able to answer those questions, but the code was directly from the book. So it means you just don't read the book if you don't know it exists there. So I really want you to read the book. It's very important. Okay, let me know if you have any questions.